All right, if you are joining me for this second video of Lesson 2 in Eureka Math, it means that you have completed your integers here and your number lines. When we grade this, the number lines aren't necessarily going to have to be exactly how mine are, but they need to be oriented similarly, which we will talk about. So first of all, the integer that represents a bank account with a balance of 0 would be 0. For my number line, I chose to put 0 in the middle of the number line to show that to the left is negatives, to the right is positive, but you could have really done any place for 0 on the number line, as long as if 0 is over here, all your numbers to the right are positive. If 0 is over here, all your numbers to the left are negative. And if it's in the middle, left are negative, right or positive. To make it a positive $150, that should have been a positive integer, 150 or plus 150. I decided to go with a scale of 5, so it's 5, 10, 15, 20. Nope, just kidding. I went with tens, 10, 20, 30, 40, 50 to show that 150 was here. Again, it doesn't really matter what scale you went by or where yours is on the number line, as long as it's definitely to the right of 0. If you didn't include 0 in your number line, that's okay. I just wanted to show you one example of how you could have done it. Again, credit an account for $150. That's a positive thing, so I just did the same number line I had done above. Making it a positive $25 is a positive integer, so it would be plus 25. And for this one, I chose to do a scale of 2, so I have 0 here, 2, 4, 6, 8, 10, which makes 25 be between 26 and 24. Again, your number line could look different, just as long as you made sure that your scales are equivalent and that you have the number to the right of 0. A bank charge of 5 is a negative 5 because they're going to charge you a fee. So I put 0 somewhat in the middle and then just counted back by ones to the left to negative 5. In this one, I would expect for you to have 0. Just make sure that negative 5 is to the left of 0. And a withdrawal of $35 would be a negative 35 integer. So again, I placed 0 in the middle. You could have placed it to the right as well. Your choice, just as long as negative 35 is to the left of 0. And again, just an example of another scale of going by 5s and labeling some of them for benchmarks. All right, now that you have that completed, we are going to go to this slide. All right, here is an example of a vertical number line. Let's see if I can make it a little bigger. And it doesn't look like I can, but temperature is commonly measured, and you don't have a paper with this on it. You're just going to have to watch your screen. But temperature is commonly measured using one of two scales, Celsius or Fahrenheit. In the United States, the Fahrenheit system continues to be the accepted standard for non-scientific use. All other countries have adopted Celsius as the primary scale in use. The thermometer shows how both scales are related. So if we look over here, we need to make sure that we're paying attention to details. Notice that there's a C above here. That tells me that this side is the Celsius measurement, and this is the Fahrenheit number line. So it's kind of like a double number line, but you have to be careful that you're looking at those details. And if it's asking you for Fahrenheit, you would go here. Celsius, you would go here. So they ask you, the boiling point of water is 100 degrees Celsius. Where is 100 degrees Celsius located on the thermometer to the right? I know it's a little bit blurry, but this is negative 20, negative 10, 0, 10, 20, 30, 40, 50. So this is the Celsius, so I need to be on this side of the thermometer. 100 degrees Celsius is actually not located on this thermometer, so it would be above 50. It is not on this current number line. On a vertical number line, describe the position of the integer that represents 100 degrees Celsius. It would definitely be above the 0 because it's a positive line, but so that's what they're looking for on a vertical number line, describing it above 0 or below 0. In this case, it would be above. So write each temperature as an integer. The temperature shown to the right. So where this number is, it goes up here, and I believe that would be going up by 10, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That would be 100 degrees Fahrenheit. It would be a positive 100 or just 100. The temperature shown to the right in Celsius, again, let's look at the scale. So here's 30, here's 40. We have 1, 2, 3, 4 in here. So would that be 32, 34, 36, 38, 40? They're going up by 2s. So that would be 38 degrees Celsius, or a positive. Freezing point of water in Celsius, they're indicating it right here. That would be what 0 means in this real world example. 0 would be the freezing point of water. If someone tells you body temperature is 98.6, what scale are they using? How do you know? So 98.6, would that be Fahrenheit or Celsius? Hopefully you said Fahrenheit, because notice that temperature, if you make connections to the summertime, temperature can be 100 degrees outside or 90 degrees Fahrenheit outside, which would be right about here. Notice that's only about 38 or 36 degrees Celsius. 100 degrees, or 98.6 isn't even on this thermometer, which means that's even higher than 100 degrees Fahrenheit, which means that would be pretty darn warm for your body to be above that. So that would definitely be Fahrenheit. Does the temperature 0 degrees mean the same thing on both scales? So again, here's the 0 here, here's 0 for Fahrenheit. So no, they definitely do not mean the same thing. 0 degrees Fahrenheit is actually a colder temperature than 0 degrees Celsius. Again, it's just learning about how to use these scales and noting what each of the marks mean, paying attention to what these numbers on this side mean, number on this side means, and thinking about numbers being located above or below 0. Something else that is going to happen on your homework tonight that I wanted to discuss real quickly